Truth tables. A truth table is a way to keep track of the truth value for statements or combinations of statements. To make sure we get every combination in our truth table, we have to set it up a certain way. We're going to start by listing every statement that is in our combination. So we have P and Q in this one. So we'll list P and Q. Those are our basic statements. Those go on the left side. I'm going to separate these with double bars to show that our P and our Q, because they're basic statements, they're like the X value. That's what we get to control. But the other values on the right side of the double line, we don't get to control. Those are based on P and Q. So on the right side of the table, the first thing that you might want to do is go through and list any negation of statements. So we have not P. I'm going to put a column for not P, and I'm going to put a column for not Q. You don't have to take the negation of every statement. It's just if it's in the original combination of statements. So first we have our negations, and then the next thing we have is any combinations. You want to start with anything that's in parentheses and then work your way out, just like a regular algebra problem, so the order of operations kind of still applies. In this case, we only have two things, so not P and not Q. Those are grouped together with an and, so we're going to write not P and not Q. But now we have our two columns, not P and not Q, and our combination together. After we have our table set up with the column headings, what we're going to do is go through and list every combination for our statements, for our basic statements P and Q. This can be kind of tricky, so you have to go about it systematically. The first thing that I do is I make them all true. So I say true for P, true for Q, and then the next thing I do is I make Q false, so true, false. And now I've got every combination where P is true, because P is true and Q could be true or false. Now I need to do, if P is false, then I've got two more combinations because Q could be true or Q could be false. So that gives me in my table 4 combinations, and we'll do one later that has 3 statements, so you'll see how to work one like that. So we've got our basic statements all filled out, and now what we have to do is use those values in the other side of the table. Alright, so the first column that we see is not P, so we're going to fill in all of our values for that. And to do that, you can look at the P column and go down with it. So the first P is true, which means our first not P is the opposite of that, so it's going to be false. Next one is true, not P is false. P is false, so not P is true. And then in the last row, P is false, so not P is true. Then we do the same thing with the Q's, so the table's going to look like this. And then after we get our not P and not Q, now we can combine those statements to figure out what not P and not Q is. For and to be true, both statements have to be true. So our table is going to look like this. Alright, so now that we've got that filled out, we actually need to look at it and interpret what it means, because it doesn't do us any good to just have a table. Oh yay, we filled out the table. That's great. What do we do with that? So we're going to analyze it, and analyzing in this case just means we're going to look at it and see what makes this statement true. So not P and not Q is only true when looking at our original statements, when P is false and when Q is false. So we have to start out with 2 statements that have a truth value of false in order to get this combination to be true. And that's the only case. In every other case, it's false. Alright, now we're going to do another example. This one's going to have some grouping in it. It's still only got 2 statements, though, P and Q. So P and Q. We start off by setting it up the exact same way. Our basic statements go on the left side of the table, P and Q, 2 columns for those. We have something being negated, but it's parentheses being negated this time. It's P or Q. That whole statement is being negated. So in this case, we can't just do a column for not P or not Q, because that's not what we're negating. We're negating that whole P or Q. So we have to put P or Q first. And then our very last column is going to be not, parentheses, P or Q. So we're negating that column that we already have. Alright, P and Q we're going to fill out the same way we did in the last table, so it looks like this. P or Q, remember for a disjunction, only one of the statements has to be true for P or Q to be true, so that column is going to look like this. And then in our last column, we have not P or Q. So we take our P or Q column, and we just take the opposite of it. And we're going to do our same analysis so that we see the only place that this is going to be true is when our original statements P and Q are both false. Which is interesting because that's how our first example was too. So if we compare the last columns from our 2 truth tables, we can see that they look exactly the same. That means that these 2 statements, not P and not Q, and the statement not P or Q, are logically equivalent because that last column in the truth table is exactly the same. Logically equivalent means that you could write either one of these statements and they mean exactly the same thing. They will have the same truth value. And we're going to use that fact later on when we start to write proofs. Now we're going to do an example where we have three different statements. So we're going to have this statement, P or, not Q and R. It looks really complicated, but the very first thing we have to do is just go through and see what our different letters are. So I see P, Q, and R. That gives me my first three columns. The next thing I'm going to look for is anything that's negated, that's a statement, not a combination of statements. So the only negation I see in there is not Q, so I'm going to make a column for not Q. And then the next thing I want to do is look for anything that's grouped together. So the things that are grouped together are not Q and R. So I'll make a column not Q and R. And then my very last column is going to be everything all together because that's the only thing that I have left to do. Alright, so this one's a little bit trickier because you have to make sure you get all the combinations. A way that we can check to make sure we have all of the combinations is we can count how many statements we started with. So we have 3 statements, and you take 2 to that power, and that'll tell you how many combinations there are. So in this case, 2 to the 3 is 8, so we should have 8 combinations when we're done. So let's start by making all 3 of the statements true. So we have true, true, true. Now the next one, let's just make one of the statements false. I'm going to start by making R false because it's on the right side. No other reason, it doesn't matter. You could do it in whatever order, it's just my brain works like this. So we make R false. So now we have the combination when P and Q are true, we have R is true and R is false. Now we have to do the same thing, but we need to make Q false. So we're going to leave P true, so it'll be true and true. Q is going to be false and false, and then R is going to be true and false. And up till now we've totally ignored P. So what we have to do is go back and write what happens when P is false. So Q and R are going to do exactly the same thing. We're going to have 2 true Qs and 2 false Qs, and R is going to go true, false, which means I have 4 Ps. So it'll look like this. Okay, so now that we have P, Q, and R, what we have to do is fill in the other columns. So not Q is pretty easy. We make sure we look at the Q column, and we're going to go through and fill in the opposite of whatever Q is. Now, for the next part, we're going to do not Q and R. So we have to make sure we're looking at the correct columns. We're going to look at not Q, which we just filled in, and we're going to look at R. Alright, now, we've got that column filled up. So our last column, we could do that now. And again, we want to make sure we're looking at the right column. So the part in parentheses, we want to look at this column. And the other one, for P, we're going to look at the very first column. So looking at those 2 columns, we have an OR in between them. So P or parentheses, not Q and R. Alright, so these are the truth values for our original statement. And this is the end of our video.
He's okay. My finger's okay too.